Okay, so we'll start with propane. So this is propane. These CH3s are equivalent to each other. The hydrogens on there are in the same chemical environment. So each hydrogen is attached to a carbon with two others on it, and then that carbon is attached to a CH2. So they're both in the same environment. These hydrogens are different because they're attached to a carbon which is attached to two CH3s. So we've only got two chemical environments. So this is 6 hydrogens here, 6 hydrogens, and the other one is 2 hydrogens. So the simplest ratio is a 3 to 1, which is the relative peak areas. So when if we're drawing the graph, would look like this, TMS here, and then if we look up the data booklet, so the data booklet for CH3s, so CH3s are attached to something else, the chemical shift is 0.9 to 1. And then the CH2s in the middle with attached to something would be a chemical shift of 1.3 to 1.4. So you'd get a peak at about 1, and it would be about 3 times the area of the peak that's at 1.3. So you get one a little bit later, and it's about a third of the height. Okay, so this peak is because of the CH3s, and this peak is because of the CH2s. So it's a 3 to 1 relationship. So when we look at the splitting, these CH3s have 2 hydrogens as neighbours. So the CH2 is the neighbouring. So that's the adjacent carbon to this. So this peak here, we're going to split it up because of these. So because it's got 2, we'll use N to represent how many hydrogens are on the neighbours. There's 2 of them. So if we add 1, then we're going to split our peak into 3, and we call that 3 a triplet. So it'll take up the same area. So if we bring it down a little bit and make it a triplet, okay, they're actually a lot closer than that. I'm just drawing it apart a little bit so that we can see that we've got 3 lines. So it'll take up the same area. It's just split up. So here, if we look, these CH2s, so this peak here, we're going to split up into 7 little parts because we've got 6 neighbours. So we'll split it up into 1, 2, 3, 4, 5, 6, 7. It's really hard to see, kind of a little mess. So if we were going from the peak back, then it's in 7. So if it's hard to see like that, they would probably put a little graph to say that it's split into 7, or it's split into a septet. And then if you're going from that to the neighbours, you'd have to say 7 minus 1. I've got 6 hydrogen neighbours. Alright, hopefully that helps. So there's only 2 chemical environments for that one. If we do ethyl ethanoate, if I draw ethyl ethanoate out here, then we've got 3 different hydrogen environments. Oops. So this one, there's no neighbours. This CH3, there's no hydrogen neighbours. So that CH3 on the end is different to this CH3 over here. And then, because that is next to a CH2, and this is next to the ester group. So there's 3 different hydrogen environments. So if we want to identify them, we can put what it's attached to. So we're looking at this CH3. If you look up your data booklet, a CH3 that's attached to an ester bond is around 2, And this CH2 here, when we look it up, we get the CH2 is around 3.7 to 4.8. And then the one on the end, I've only really got this one that we can refer to. That would be probably a bit higher because it's next to an oxygen. So it would probably be a bit higher than 0.9 to 1.0. But that, when we're drawing it, this one on the end is going to be probably at the lowest. And then we've got this one here, which will be further up. So if we just drew it as at low resolution, this one on the end is worth 3 hydrogens. And then the next one up is this one on this end, and it's at 2 parts. So this is at about 1, and this is at about 2, and you've got something that's worth another 3. And then their highest one is for the CH2s. So it's around, so we've got 3, 4, it's around here somewhere, and it's worth 2. So 3, 3, 2. So when we look at the splitting, so that one is that one, and this one is that one. When we look at the splitting, if we do the splitting for this one here, it's got no neighbours, so it won't be split. That'll be our singlet. And then the one here, the first one, for this one, it's got 2 hydrogen neighbours. So it's got the CH2 on it. So the number of hydrogens on the neighbours is 2. 2 plus 1 is 3. So it's split into a triplet. So this is split. This is there because of this CH3. It's the lowest one because of the CH3 attached to other hydrogens. And it's split because it has 2 hydrogen neighbours. So the peak is there because of that. It's split because of the neighbours. So kind of repeat that to yourself. You know, the peak is there because of that, and it's not split because there are no neighbours. This peak is there because of that, and it's split into, it's got 3 hydrogen neighbours. 3 plus 1 is 4. So it'll be split into a quartet. So 1, 2, 3, 4. They'll be closer together than that. So hopefully that helped. Need to be careful. We're talking about hydrogen, NMR, or we're talking about carbon. So if we looked at carbon, we've got 1, 2, oh, that's wrong. Maybe that's why you're confused. 1, 2, 3, 4 carbons. So we should have 4 carbon environments. So that should say 4. Maybe I just did all of that for that question. Okay. So I'll need to change that on my answers. Okay.